Have you ever felt anxious and suddenly your stomach tightened? Or experienced stress and your digestion changed the next day? What if your gut wasn't reacting randomly? What if it was translating stress into biology? Most people think digestion is just about food, but your gut contains over 100 million neurons. It produces neurotransmitters. It communicates directly with your brain. It influences inflammation. It affects blood sugar. And it even impacts your mood. And at the center of this conversation is a small but powerful organ, your pancreas. Today, we are going to explore the gut-brain-pancreas loop. Because persistent bloating, energy crashes, sugar cravings, irregular digestion may not be isolated symptoms. They may be a conversation happening inside you. This is Health Reimagined. And today, we decode the second brain. The digestive tract contains the enteric nervous system, often called the second brain. It operates semi-independently. It regulates motility, enzyme secretion, immune response, inflammatory signaling, communication via the vagus nerve. Your gut constantly sends information to your brain. In fact, most signals travel upward, from gut to brain, not the other way around, which means digestive imbalance can influence mood and cognition long before pain appears. When you experience stress, cortisol rises, adrenaline increases, blood flow shifts away from digestion, motility slows or accelerates unpredictably. Chronic stress alters the microbiome. It increases gut permeability. It promotes low-grade inflammation. Over time, this can lead to bloating, irregular bowel movements, food sensitivities, abdominal discomfort, brain fog, mood instability. The gut is translating stress into physical sensation. And most people treat the symptom, not the signal. The pancreas regulates blood sugar. Every time you eat carbohydrates, blood glucose rises. The pancreas releases insulin. Insulin allows glucose to enter cells. But here's the key: chronic stress raises blood sugar even without food. Cortisol signals the liver to release glucose, which means stress alone increases insulin demand. Over time, insulin sensitivity declines, blood sugar becomes unstable, energy crashes increase, sugar cravings intensify. This is not diabetes yet. This is the whisper phase of metabolic dysregulation. Have you ever felt clear-headed in the morning, energized after coffee, then crashing mid-afternoon? Craving sugar or carbs? This pattern often reflects blood sugar instability. Blood sugar spikes. Insulin spikes. Then glucose drops rapidly. The brain perceives danger. Cravings appear. This cycle stresses both pancreas and liver. And the gut feels it, because unstable glucose alters motility and microbiome balance. Your gut bacteria influence inflammation, insulin sensitivity, neurotransmitter production, appetite regulation, and imbalanced microbiome ca. Increase intestinal permeability, promote systemic inflammation, impair glucose metabolism. Chronic stress reduces microbial diversity. Poor diet shifts bacterial composition. Sleep deprivation alters microbial rhythm. The gut-brain axis is a full ecosystem, and imbalance echoes across systems. The gut produces significant amounts of serotonin. When gut inflammation rises, neurotransmitter balance shifts, which may contribute to irritability, low mood, anxiety, mental fog. People often separate mental and digestive health, but biologically, they are intertwined. Chronic bloating is not just digestive. It may reflect inflammatory signaling affecting the brain. Chronic low-grade inflammation impairs insulin sensitivity, disrupts gut barrier integrity, increases vascular stress, alters brain signaling. You don't feel inflammation directly. You feel brain fog, fatigue, mood instability, digestive heaviness. Inflammation connects the gut, pancreas, liver, heart, and brain. This is a systems conversation. Sleep deprivation reduces insulin sensitivity. Even one poor night can increase blood sugar variability. Chronic poor sleep elevates cortisol, disrupts appetite hormones, increases cravings, promotes weight gain. Weight gain increases insulin resistance. Insulin resistance stresses pancreas. Pancreatic stress alters digestion. The loop continues. Sleep is not passive. It is metabolic regulation time. The vagus nerve connects gut and brain. When vagal tone is strong, digestion improves, heart rate variability increases, stress resilience rises. When vagal tone is low, motility becomes irregular, stress sensitivity increases, inflammation rises. Breathing practices, cold exposure, and mindfulness can improve vagal tone, which improves gut-brain communication. Highly refined foods spike glucose rapidly, increase insulin demand, promote fat storage, reduce microbial diversity over time. The pancreas compensates by releasing more insulin. Chronic hyperinsulinemia can precede insulin resistance. This phase can last years. During this time, people feel energy instability, hunger shortly after meals, abdominal bloating, brain fog. The body is compensating. But compensation has limits. Before diabetes, there is often elevated fasting insulin, slightly elevated fasting glucose, increased waist circumference, post-meal fatigue. Most people do not notice early insulin resistance because glucose may still appear normal. But energy patterns shift, cravings increase, sleep worsens, inflammation rises. The gut often becomes more reactive. The whisper phase is metabolic instability. Ask yourself, do I crash after meals? Do I crave sugar in the afternoon? Does stress immediately affect my digestion? Is my bloating persistent? Has my waist circumference increased gradually? Do I wake tired despite sleep? Individually, these mean little. Together, they tell a story. The gut-brain-pancreas loop responds well to early intervention.